My name is Khaleel Ahmed. I'm the trainer. Okay, let's go on to understand what we have in today's session. What is it that we can do with Ruby is what we are trying to understand in just about 4 hours. A quick brief as to what we may be looking at. Ruby is a cross-platform 4th generation purely object-oriented, no limits programming language. Some of the things which may look at include in 2 steps, basic and advanced. We may look at how to make a script cross-platform, how to write comments, how to create variables, the I/O statements, the relational operators, the conditionals, the loops, the data structures, how to work with files, exception handling. We'll also look at object-oriented programming, database access, CGI scripting, socket programming, XML parsing, multi-threading, web services, and working with TK for front-end. Some of these we may be looking at code examples, some of these we may not be looking at code examples depending on the functionality available, because I'm just working on a Windows box and I don't have a Unix box with the various things that I can show you a few things. So most of these we may be looking at some code examples too. This is not an extensive course to make you a Ruby programmer. This is just to understand, is Ruby useful in the projects which we are working at our organization. That's the focus of this particular training. Maybe there are more features which are not listed here. These are some of the features. In the interest of time, we may not be able to go into the depth of all these topics which are listed here. So let's go on to see how we can make the script cross-platform. When you're working with programming languages themselves, what we have seen historically is there have been programming languages where hello? The screen is shared. Okay. When you're working with a programming language, we know historically we used to have programming languages where the applications used to live and die on one operating system. If you go back to the games which we have played when we were school students, we understand that we were addicted to such applications, such games, but today we don't see those games on our boxes because those applications were designed for one operating system only. Going forward, what happened was people started using programming languages where the programming language was available on more than one platform so that they could port an application. And today what we see is we see a lot of maturity in programming languages themselves. We are looking at cross-platform programming languages, meaning you write a script on one operating system and you want to share that particular hard disk in the form of map drive on Windows and in the form of NFS, that's your network file system, on your Unix platforms. When you're working with cross-platform scripts, we have Perl, Python, TCL, Ruby, all these are cross-platform scripts. And these cross-platform scripting languages allow you to take care that your application is written on one box and you can execute it on multiple platforms. To make your script cross-platform, you'll need to make sure that you have the #usr/bin/ruby on all your scripts. Why is that so? Because on the Unix operating system, it is going to check the first 2 characters. If the first 2 characters in the file are hash and exclamation mark respectively, then the rest of the line is treated as the interpreter. And the file is passed as a parameter to that interpreter. When you're working with the Windows operating system, we have the concept of associating an extension with an application. As we have the concept of associating an extension with an application, on Windows, we have the .rb extension to associate the Ruby interpreter with our script. All your Ruby scripts which you're going to write will have a .rb extension and will also have a #/usr/bin/ruby. The .rb extension is to take care on the Windows based operating system, and the #/usr/bin/ruby is to take care that your script does not complain on your Unix platforms. Does anyone have any doubts or questions here? Okay. I'm sorry, could you come back with the question again? Do we need to? See, you mean for this particular session? You may not have time for hands-on. I'll be giving demos, so you may not want to be trying out things. You can actually, Correct. You will need to install Ruby. Ruby is available with GNU license, so you can freely download for your Windows box as well as on the Unix box. On Unix, it's available as a part of the installation itself. In case it is not available, then you can request your administrator to install it for you. Hello? Okay. So when you're working on the Windows operating system, you can download it directly and start working, whereas if it is on the Unix operating system, if you happen to be an end user, in case it's not available, you may want to request your administrator to do the installation for you. In case you're working on the Unix operating system, you can execute the command which Ruby, and it will show you which is the Ruby interpreter which is available to you. It will show you a /usr/bin/ruby. That's the standard location where Ruby is installed. Does anyone have any questions? For you to try out Ruby on your local system, if you're working on the Windows operating system, you can download it. You can just Google, you'll find Ruby downloads available for free. You can install it. Let's move on to see what we have. You can write your comments. For single line comments, you can start with hash. Now this is the standard for all scripting languages. You have hash as the comment character. Whether it is shell scripting, Perl scripting, Python, TCL, Ruby, all of them have hash as a comment character. You can use it at the beginning of the line to comment the entire line, or part of the line after the command. You want to comment out whatever that command is doing, you could do it in this form. And in case you have multi-line comments, you can have the begin end block, starting with equals begin and ending with equals end. This will take care that whatever code you have written here will be commented out. Ruby is a 4th generation language. As Ruby is a 4th generation language, you'd find it very easy to learn because it's more of spoken English. So let's go on to see what are the rules we have. Let us go on to learn how to create variables. When you're working with variables, variables are case sensitive. You can use alphanumeric and underscore as a part of your variable names. Here are examples. give x is equal to 10, x is equal to good morning, and you'll see that it is going to directly show you, directly create the variable for you. Are you able to see my prompt, C:prompt? Yes. I'm executing a command called IRB. IRB is interactive Ruby. If you just give RB, then it is Ruby interpreter, which will not be interactive. It will be more like Perl, where it doesn't give you any prompt. You're supposed to give all the commands and work with it. Now let's try out what you have seen there. I'm giving x is equal to 10. It shows you 10. If I just give x, it shows me the value. Now this is for the interactive stuff. You could use put as x. You'll be able to see the value. You could also use the print statement. You could use the print statement, so you could get to the value. Now the same variable, you could find out what is the data type, what is the class to which it belongs by using a dot class method. I could either give it in this form or in this form. It is going to tell me what is the class to which it belongs. Note that we did not give an int x to create a variable. We just gave a x is equal to 10. Now I am giving a x is equal to good morning. Now it did not complain that I have given a different class of data to a fixed number. You could give a 10.0 and find out that it is not a fixed number, but it is a float. Now depending on what is the value, it is going to determine to which class the object belongs. It's going to determine to which class the object belongs. So this is how you can comfortably work with Ruby in the interactive session. When you're working with variable, the variable will tell its story. All your local variables, you just create the variable the way I created an x is equal to 10. You would create your variables. You could use all lowercase with an underscore, any alphanumeric you could create. If you're creating a constant, you can use the first character, that is the initial character, to be in capitals. That will make it a constant. In case you use dollar variable name, then it is a global variable. In case you use dollar variable name, it's a global variable. When we come to object-oriented programming in the advanced section, we will see the concept of instantiation. We will see the class variables and the instance variables. This is how you would create your class and instance variables. For a class variable you use @, and for an instance variable you use the @. So what is that supposed to be? In case you are new to object-oriented programming, don't worry at this point. We will look at it once we come to object-oriented programming. Does anyone have any doubts here? Okay, let's move on to see what we have next. Let's go on to see what we have with the IO statements. Let me again get the interpreter on the screen. Sorry. So let me get the interpreter on the screen. And let's go on to see some examples. So we have seen how to work with variables. We have seen how to work with comments. And let's go on to see some IO statements. The input input statement and the output statement. We have briefly looked at the print statement. And there what we have seen is we created a variable and we displayed the value of that variable. We created a variable and we displayed the value of the variable. So let me give print good morning. So here it is showing me a good morning. I could use a put as, and I use a good morning. Now what I will do is I will open a file in Notepad. Let me call this as io.rb. Sorry, not the right place. Notepad io.rb. So I'm creating, let me share that with you. So here comes your io.rb. What I'll do is I have some code ready with me. So I'm going to get that code. I will do a copy paste in the interest of time. And here is the code for us. All our Ruby scripts will have a hash exclamation /user/bin/ruby, right? And this is the script which I have. I have the script which says print good morning, print good afternoon, print good evening, and I also have the print with the new lines. So I'm saving this and I am going back to my prompt. So I'm executing this io.rb. Let's see what it does. So it is giving me good morning, good afternoon, good evening, all on the same line, as well as the good morning of the next one. So let us see the contents of the file io.rb. The contents of the file are print first without the new line at the end and then with the new line at the end. So when you're working with print, it does not concatenate a new line at the end of the string. It is going to show you the string as it is, because the last print here without the new line did not concatenate the new line. We are able to see the good morning of the next line on the same line as good evening. Okay, so now what I'll do is I will further modify this code, and what I will do is now instead of a good morning, good afternoon, good evening and the print statement, I am going to use a different statement now. I'm going to use a put as statement, and let me show you what I have in the contents. So here I have put as good morning, good afternoon, good evening. Note that I don't have a new line here, and I'm executing this io.rb. So first you got to see these, which is without the new lines, and then you had the new lines with the print, and then you have the put as. I did not specifically give the good morning, good afternoon, good evening messages with the new line, but you see the new lines are inserted. Now how is this happening? Because put as by default concatenates a new line at the end of the string. Any doubts so far? So that was simple. So what we will do is we will go on to add some more code here. So we have seen how to display the output. Now we will go on to get some more code so that we can add to this existing script and get to see the output. So let me clear the screen and show you the contents. Now the focus is on the last 4 lines. The first few lines we have already seen. Last 4 lines we are giving a print, enter your name, and then we are giving a get as, and we are showing the length of that string as well as the value of the string. Let us execute this. So when I execute this, it is asking me enter your name, and I enter my name, and it is telling me the length as 8. But when you count the number of characters, it is not 8, it is 7. That's basically because it has concatenated a new line. Did it concatenate? Not really. The enter key which I pressed was also stored in the variable which I've created. So what can we do with this? Those of you who have worked with Perl have used a function called jump. So what I'm doing now is I'm using the function called jump along with this. So now when I enter my name and hit the enter key, it is giving me the length as 7 rather than 8. You would find that in case you have worked with other programming languages, all this is very simple for you. Why is that so? Because being a 4th generation programming language, you see that you have a print statement, you have a getS, which is to read a string. You see getS not only in Perl, you also see it in other programming languages inclusive of C. So we see that you are able to relate to the existing knowledge which you have, and you can take that further. Yes. It was showing 8 because it also retained the new line which you entered. When you typed in your name and hit the enter key, that enter key also gets stored in the variable. Okay? It happens in Correct. That's an interesting question. So what I'll do is I will modify this same code. Now instead of enter your name, I will give enter a number. So I'm modifying this, and now what I do is I'm going to retain it as it is with the word name, but I have given enter a number. Now what I do is I'm going to remove that chomp there. Why am I removing the chomp? Because we need to understand what happens before and after the chomp in this case, and this we know very well that it has accepted it as a string earlier. Let me execute this. So here is the execution. I gave 10 and it says length as 3, so you are 10. Now what I do is I will check out what is the type. Instead of length, I am going to give class now instead of length, because we need to find out to which class does this object belong now. I'm giving 10, it says length, I retain the string as it is. So the code I have given is this, and this is what I have executed, and when I give 10 it says it is a string. Name.class shows it's a string. Now the question we have is, how can I accept a number? So the getS function, you need to give a small modification to that. Now let me re-execute this and enter the number. Now it says it is fixed now. It says it is a fixed. Why does it give that it's a fixed now? Let us see the code now. Now before I show you the code, I will re-execute and I will give, let's say 21.543. It says fixed num. Now let's find out what it is showing you. Observe that it says 21. Okay, I have taken 21. I have not taken, earlier I took 10. It showed fixed num, it was matching, but now it is showing fixed num for a 21.543, but then it says the value it received was 21. Let me show you the code here. The code here is getS.to_i. So when I give a to_i as a method of getS, it is going to get the integer. Now I'm going to modify this so that we can accept float. Earlier we did not see this, so now I am changing this to making a small modification here so that we can see the modified values. So here is the code which I have. So I'm having getters dot to underscore I, getters dot to underscore f. Now we will re-execute this, and in the number I'm giving a 10, and it says it's a fixed num. In the real number I'm giving 12.345, and it says it's a float, and it is able to retain that entire value. Any doubts here? Okay, so we have seen how to display as well as how to accept the data. Observe that when I gave this particular piece of code here, that is the putS, I have used putS with a hash name.class. Now why have I done this? I can use this along with the string. I can use this along with the string. But if I don't want to have the string, if I just want to display that value, then I can just give a name.class and I can get just that value. If you choose to display value of a variable along with another string, then you'd use this particular syntax with hash and flower brackets. Recall your printf of your C programming. You gave a %d and then you gave the variable after the quotes. So this is how you're going to do it in Ruby. I mentioned that Ruby is a no limits programming language. What is that supposed to be? We will see that shortly. So here I'm coming back, I'm bringing back your presentation. If you just give a getS, you're accepting a string. If you give a getS with a to underscore s, that is also accepting a string. If you give a to underscore I, it is going to accept an integer. If you give a to underscore f, it is going to accept a float, a real number. Let's move further. Let us see what we have. Yes, sir. Why would you need it with putS? putS is going to display a string. So let us do it. Let us do it on the system and find out what it requires. So I'm bringing up the session for you. So here is my interactive Ruby. I have a putS with x. Observe that x has a 10.0. I don't really need it. I don't really need it. Okay? When I use a print x, I don't really need it. It's only when I'm reading that I need to find out. When we work with Ruby, Ruby is a dynamic programming language. It uses dynamic typing, also referred to as duck typing. What does it mean? Depending on the type of value you give, Ruby decides what should be the class to which the object should belong. Because it is going to determine based on the value. putS is going to determine based on the value. getS is not able to determine based on the value because by default it is looking for a string. If you wanted to convert to a number and give it to you, you will have to use the appropriate method of the getS object. Does it make sense? You want to give a x dot to underscore I? Let's find out. It is going to work. But the question is, do you need it? Because it is dynamic typing, you don't really need it as such, unless and until you are doing some calculation. Like for example, if I'm doing a calculation with a multiplied by 10, then I may really want to make sure that I don't have any mess up there, like in In both the cases, it is giving you a similar output, but you do not want any mess up. In the second case, it is a 10.0 which is available in X. When you look at it on top, let me highlight that. So X has a value 10.0. Here I am converting it to an integer and doing the multiplication. If I give a get S, or let me directly give an X is equal to 10, I'm assigning a string to X, and the X dot class is giving me this as a string. Now if I do a print X into 10, it is going to give it to me like this. This is the reason why you would like to explicitly do it, but if you're just displaying an X, you don't really need it. In this case, what is happening is when you give a X star 10, it is showing you 10 times. Let me just reduce this so that we can appreciate it. I give 2, so it is showing me 3, is showing me that. Okay, so it is going to show the same character multiple times. If you work with other programming languages, there are some programming languages which support this. Apart from other programming languages which support this, even Perl supports this particular feature. You can show the same character multiple times using the star operator. So in the context of a string, because it is dynamic programming language, in the context of a string, it is going to show the same string multiple times. But in the context of a number, it is going to show you the multiplied value. Any doubts here? Any questions? Okay, so let me share the presentation with you again. Share the presentation with you again. So here is your presentation. We have seen the print with the put s, get s, print, put s, get s, and get s with some methods. Okay. Let's go on to see some operators here. You have the arithmetic operators, the relational operators, and the logical operators. When you're working with arithmetic operators, you have the plus, minus, slash, star, percentage, and double star. So what does it mean? Let us try and understand. You have the plus, which is the addition, minus is the subtraction, slash is the division, star is multiplication, percentage is modulo, double star is exponentiation or power of. So let's go on to see what you have. I have x is equal to 10. And y is equal to 20, I can give z is equal to x plus y. I get to see the value 30. Z is equal to x minus y. Z is equal to x divided by y. 10 divided by 20 is giving you 0. That's because it is treating it as an integer. Now, in case instead of giving a 20, if I do a 20.0, it is going to give me the 0.5. Either I do it in this form or I give a 10.0. Either case is fine. One of the values, if it is a float, it is going to give you the float value, the real number. Then we saw the multiplication, the modulo, percentage is a modulo. Now let me show you what we have with the double star. I give 10 double star 2, it shows me 100. Let's say 5 double star 2, it shows me 25. 5 double star 3, 125. And if I give, let us say, 99 double star 99, let's find out what it does. So this is 99 power 99. Let's increase the number here. Both the sides I'm increasing the number. Observe that within a fraction of a moment, it gave you the output. What is 999 power 999? It's a huge number. It's, as I mentioned, Ruby is a no-limits programming language. Ruby is a no-limits programming language. You could choose to increment this further. You could choose to use higher numbers. Absolutely no problem. Just that the calculation has completed and it is taking time to display the output. The output is so huge that it is taking time to display. I have a question here. Is this a good number to see in your bank account? Is everybody awake? Is everyone with me? I don't get to hear anyone. Hello? Are you able to hear me? You're able to hear me? Okay. So my question was, is this a good number in your bank account? Looks like people are bowled out. Okay. So we see that it's a no limits programming language. Now it's going to continue. So let's go on to the other operators which we have here. You have the plus equals, minus equals. So this is something, if you are familiar with the C programming language, you would have seen. So let me get the session again. I'm getting a new session because the other session is still showing the numbers. So let me show you what we have. I have x is equal to 10. I can give x plus equals 1. That became 11. X minus equals 1 became a 10. X slash equals 2. So that makes it x divided by 2. So that is 10 by 2 is 5. X, let's do a mod of it. So it shows you 1. And x into 2. That's multiplied by 2. So we can do all this stuff. Let us say I do a x double star equals 2. That's a 2 into 2. So if it is 4 over 4, it is 256. Okay? So you have these operators which are the shortcut notation for an x is equal to x plus 1 or a y is equal to y minus 1. So these kind of things, you have shortcut notation which is available. The relational operators, as I mentioned, it's a fourth generation language. These are operators which you have already learned earlier. Nothing new to you. The less than or equal to, double equals, exclamation equals, greater than or equals, and greater than. When you're talking of logical operators, you have and, double ampersand is also and, the word and is also and, or is also an or, so is the double pipe, not and exclamation, both are not operators. So this is more of spoken English. We'll see some examples going forward when we come to the next topic where we go on to the conditionals and loops. We will need to use these relational operators and the logical operators. The question mark colon, people who work with C would have definitely seen this. This is the ternary operator. So we have seen some examples with respect to arithmetic operators. We will see the other operators when we move forward. Any doubts, any questions? Let's move on. The next topic we explore is the conditionals. You have the if, else, end. So that's how you have your conditionals coming up. And what we will do is we will go on to see the usage of the if and else. I think we will go ahead and work with a script in this case. So allow me a minute, I'll just get some code there so that you can get to see some script there. So what we will do is, in this particular script, we are going to create a script which is where we are going to have a script which is going to accept the day of week. If the day of week entered is let me first create the file for you. So I'm creating a file, notepad, let's say, because we are working with if and it is related to day of week, I'm calling it as if_day-of-week.rb. So I'm going to share this particular notepad with you. Are you able to see the notepad? So let us go on to write this script here. So first of all, we would like to accept the input. So we will give a putS there. We will give a putS, enter the day of week, and then what we will do is we will accept the day of week in a variable called DOW. Day of week is equal to, I'm going to use a getS. Now we know that this is a string and we need to make use of charm so that we can get just the string. Now we are doing a comparison here. If day of week is equal to Monday, or day of week is equal to Tuesday. Note that I'm using the word or day of week is equal to Wednesday. So what am I doing? I'm using the if with two kinds of OR operators, both which are available. I'm using both of them. And now what I do is I am going to give a putS timings 9 a.m. to 6 p.m. Okay, so now what I've done is I've just created a small script, and whenever you're working with the conditional if, you have to have an end to indicate that is the end of the code. So I'm saving this and going back to my session where I can show you the code. Here I'm executing the code for you, and it is asking for the day of week. I enter Monday and it is giving me this. I give Tuesday or Wednesday. For all of them it is giving me this, which tells us that this particular program which we have written, where we have used both OR as OR as well as the double pipe, both are working fine, due to which it is showing us the timings as 9 to 6 in all the three cases. When you're working with the conditional if, you can go in for multiple conditions. So let me get you the notepad again. So here comes your notepad. So now what I'll do is I will bring in the else if day of week. Let me just copy this here so that it saves our time. Else if, let us directly give Saturday. Else if Saturday, then I'm going to do a putS. So here comes my putS. I also do another else if, you can have any number of else ifs. That's what I'm trying to show you here. So if it is Sunday, I am going to indicate a holiday, and I will also bring in else right here because it's very simple. Put as invalid day of week. Okay, so let me save this and show you your session again. Sorry, let me save this and show you your session again. So here I'm showing you this particular program, and this is the execution of the program. We have already seen Monday, but still I'm giving you Monday, and now I'm directly going on to Saturday to find out if it is still valid, and Sunday. Incidentally, we did not take care of Thursday and Friday, so whatever I give apart from those is going to give me an invalid day of week. Okay, so we have seen the conditional if, where we have seen the if, the else if, the else. So all of these we have seen. We have seen the or, both in the form of or as well as the double pipe. Let us make a small modification here. Let us go on and remove that chomp method which we have and find out what happens when the chomp method is removed. Why am I doing this? Because initially when you start off, you will realize that you may forget this, and when you forget it, you'll find that it is going to give you with an error message. So I'm giving a Monday and it says invalid day of week. So if you find that whatever you enter gives you an invalid day of week, or whatever you enter goes to the case else, the else part of it, it simply means that there's something wrong with what you're accepting and you need to fix what you have accepted. You will need to use the chomp method there. Does it make sense? You do have, yes, you do have methods using which you can do case conversion. We will see that moving forward. We do have functionality where you can do case conversion. So you can accept Monday in lowercase or uppercase or proper case or mixed case, whatever, and it will allow you to see it in the, it will allow you to compare in a certain case. Any doubts or questions? Okay, so let me get your slide deck again. So we have seen the if, else, and it has to end with the end. So the next construct we see, the next conditional we see is the case. With the conditional if, we know that you have too many conditions to be checking. Let us find out what is the flexibility which is offered by the case construct. What the case constructor does is, it allows you to do a comparison, but instead of doing it the way we have done in the conditional, where you did day of week is equal to Monday, or day of week is equal to Tuesday, or day of week is equal to Wednesday, you have a much simpler way of working. So what I'm going to do is, I'm going to take you to your session again. Let's start a new notepad, and let's bring in, we'll call it as case day of week, and what I'll do is I will put this piece of code related to the same program using case now. So here I give put as enter the day of week, and I am reading the day of week using getters and jump, right? That's what we did earlier also. Here what I do is I give case day of week, and I give when, and I can give Monday, Tuesday, Wednesday. I can give that in quotes. So here I'm just using Monday and Tuesday. I'm not giving more than that. And here I'm giving a put as timings 9 to 6, saving some time there. And similar to this, when you're having a Saturday, similar to this, when you're having a Saturday, you'll have Saturday 9 to 1. Okay, and I'm not giving you a Sunday here. Anyway, that's simple stuff. Now I'm giving a else here, and I give a put as invalid. Okay, and I need to give an end. So let's see what you have here. So here is your piece of code where you have put as enter the day of week. Day of week is equal to getters dot jump, case day of week when Monday or Tuesday, put as timings, when Saturday, put as timings, else put as timings, or whatever message, and end. Let us see if this code works for us. So let me take you back to your so here is what it is showing you. I give Monday, it shows me this. So this is your case day of week, and I have given Monday, so it is giving me 9 to 6. Now I go on to give, let us say, Tuesday, says 9 to 6, and I have only given Saturday. If I give Sunday, it is taking me to invalid. If I go give a Friday, it is again taking me to invalid. Saturday, it is showing me the timings is 9 to 6. Okay, so when you see the code with respect to the case, we see that this is with respect to if. With respect to case, when you see the code, you see that it is much simpler as compared to the conditional if. With conditional if, you had to do a day of week is equal to Monday, day of week is equal to Tuesday, day of week is equal to Wednesday. If it is 10 times, you had to do the repetition, because when you're working with the conditional if, the expression before and after the compound operator has to be complete. The expression before and after the compound operator has to be complete when you're working with the conditional if. When you're working with the case, you just have a variable and you're checking out what is the value of that variable. That's how you're working with it. Any doubts so far? Any questions? Okay, so let's move on. Let's move on to see what we have with else. What we have with unless. Unless is the opposite of if, but it has a slight difference as compared to if. Anyone used unless anywhere else in any other programming language? Is unless available in any other programming language? unless is also available apart from other programming language, just you have it in Perl. So I'm showing you an unless.rb. So let me get that on the screen. So that's your unless.rb. So when you're working with the conditional if, you can have multiple conditions, meaning if, else if, else if, else if, else if, you can have any number. But when you're working with unless, you only have an unless and an else. So let's go on to see the code with respect to unless. As this is not very important for us, as we are working on Windows, I'm not giving that in the interest of time. So I have unless, okay, let's implement the same program what we have done. I'll just do some copy paste with the earlier code which we have written with the putS and getS. So we will save some time there. So I'm giving a putS and a getS chomp. Okay, so unless day of week is equal to Sunday, which we want to indicate as holiday, so I'm going to give a putS holiday for this, and I will give a else. I'll give putS timings. Okay, let's say I give 9 to 6, and I give an end. So what are we doing here? Let us try and understand. With unless, you don't have the concept of multiple conditions the way you have else if in the if. So let us save this particular program and go back to our session. Let's go back to our session. Here's our session, unless.rb. So we had done some copy paste, so we got some code from there. No Ruby script. Looks like I didn't save that file. Let's hope that it is an RB file, but it says no Ruby script found in input. Let us find out why. Let us modify the code and give something here. And let me re-execute. It is working. So let us complete this. I'm giving Sunday, and it says 9 to 6, and I give Monday, it says holiday. Observe that, as I mentioned, unless and if are opposites to each other. So because they are opposites to each other, I should have actually flipped the things, flipped the values there. Let me get the code for you. I should have flipped the code for you. I should have given a putS holiday for the else part of it, and timings for the unless part of it, because if and unless are opposites to each other. If and unless are opposites to each other. Now the question is, what is it that I did between one moment. Let me get this. Okay, that is completed. I'm just closing this for now and exiting out of this. I'm opening the other session. So here's the session. I'm giving unless.rb. Enter the day of week. I give Sunday, it says holiday. I give anything else. Let's say Friday, it says 9 to 6. Okay. So if and unless are opposites to each other. So they flip the way they work. It is always advisable that you use the conditional if. It's a very rare case scenario that you want to have a negation the way you are working with unless. So it is better we stick to one of the two rather than get confused. Another reason why you should stick to the if is because if gives you too much of flexibility. It offers the else if any number of times, whereas unless doesn't offer the same. That's what it is. Most programming languages offer this. You can continue. Correct. Right. As I mentioned, unless doesn't give you the flexibility, whereas the conditional if gives you the flexibility with the else if. Okay. Sometimes we are working with negative test. In such cases, you may want to look at this. Otherwise, you don't need it. Like for example, I'm only looking for Sunday. I'm not looking for anything else. Then probably I may want to use this. But it's an extreme case. It is better that we stick to if, because that can serve the purpose of either the if or the unless. You just have to change the operator. Instead of equals, if I do a not equals, then the if actually became an unless. So let's go on to take the next step. Let's see what we have with the loops. With the loops we have while. Another form of while is the begin end while. Then you have until, you have a similar until, you have the for, the break, the next. So these are some of the things which are available in looping. Let's go on to see some examples with the loops too. So let me create a while loop example. Let me bring up that notepad for you. So here is the notepad. I have a counter, let's say CTR is equal to 1, while CTR, that is not from my side. Those of you who are not using your phone, probably it would help you muting it. Is it okay now? Okay. While CTR is less than 10, let me save this and I will execute this. Let us find out what it does. So here it comes. It is giving me these values. Let me show you the code. I have given CTR is equal to 1, while CTR is less than 10, put as CTR plus equals 1. Now what I will do is, I will make a small modification. In this modification, what I am doing is, instead of having the CTR plus equals 1 on the next line, I have put it on the same line and I have commented the next line. Now I am re-executing this. Let's find out what it does. It starts with 2 and goes on to 10. Earlier, it started with 1 and went on to 9. Now it is starting from 2 and going to 10. Why is that so? We have CTR is equal to 1. put as CTR plus equals 1. It has incremented the value and displayed that value and then gone on to the next iteration. So we have both ways of working. You could put it as a part of your display statement itself, or you could have it as a separate increment statement. When you're working with the condition while, let me bring that session there so we understand what we have. For some reason we have the while do end. If you observe carefully, I have not used the do statement at all. I have not used the do statement at all in this particular script which we have seen. So let me just give a do here and find out what happens. I will bring up the session for you and show you what it shows you. Observe that the output is the same. There's a possibility that I might not have saved the file. So just to show you that I have actually saved a file, I am showing you the contents. The do here is optional. If you look at other programming languages, you have the while do done. Here you have while condition, set of statements, and do is optional for us. Do is optional for us. Any doubts, any questions? We have another form of the while loop. The other form of the while loop which we are seeing is the do while kind of a syntax. When you're talking of the do while kind of a syntax, what we see is in the do while kind of a syntax, first you are going to execute the set of statements and then you are going to look at the condition whether it is satisfied or otherwise. First you are going to execute the statement and then you are going to check out. So instead of begin, I am giving a do while so that we understand that this is similar to do while. Let me get that notepad open for you. So I want to have a begin put as CTR. That tells me that I need to have a CTR defined. So I give CTR is equal to 1. Put as CTR plus equals 1. Let us just give while CTR is less than 10 and find out what it does. So I'm getting the session where we can execute it. So this is my do while. It says while CTR is less than 10, it says syntax error. Now why did it give this syntax error? Let us try and understand. In the begin end, when you are working with while begin end, you need to give that end there, otherwise it will bounce off with an error message. That's what it is showing you. So what I'll do is I'll quickly make a modification there. I'll put an end there. Save that and come back. Let me show you the code so you know that it is the modified code which you are seeing. So this is the modified code which you are seeing. Let us see if this is going to work for us. Incidentally, it worked. So the end there is important. Why did I show this to you? When you worked with the while loop, you gave while condition and do was optional, and we had the code and we had end. The end here is not optional. In other programming languages, you have flower brackets and you put the piece of code and then directly you give while condition, and you know that there is no begin end there. It is represented in the form of open and close flower brackets there. So we have seen the usage of the begin, end, while condition. So this is the second form of the while loop. The third form of the while, the next loop which we explore is the until loop. The next loop which we explore is the until loop. So let's go on to see what we have with the until loop. The until loop is opposite of the while loop. Until loop is opposite of the while loop. So let's go on to see an example of the until loop. When you're working with the until loop, with the while loop, the while is testing if the condition is true. With the until loop is checking if the condition is false. So I have a piece of code here. Let us see the execution of this code. Let us see the execution of this code. So here is what it is executing it as. We have given CTR is equal to 0 until CTR is greater than 4. Until CTR is greater than 4. Meaning as long as CTR is less than 4. When it becomes greater than 4, you don't want to continue. While and until are opposites to each other. Again, as I mentioned earlier, with respect to if and unless, please use one of the two. In our case, it is best that you stick to the while loop rather than work with both while loop and until loop and get confused. So it is best that we stick to only one loop. When you're working with the conditionals and the loops, we also want some control on what we are doing. We want some control on what we are doing. So we have the break and we have the next, which we'll be seeing shortly. But before we go on to break and next, let us go on to see the next loop. The next loop which we have is the for loop. So let me show you the code for the for loop. When you're working with the for loop is used for you to process a list of values. Before we continue, with respect to the until loop, you have similar to your while loop where you have while and do while kind of a syntax, that is the begin end. The same kind of syntax also exists for until. Let us see what we have with the for loop. But before I go on to show you the for loop syntax, before I show you the code, let us see something. I gave 1.5. This 1.5 will expand to a range from 1 to 5 when I gave it in the for loop. When I give it in the for loop, this expands to a range. So what I'm going to do is, in the code which I'm going to be writing, I'm going to quickly do some copy paste. I have the code ready for you, so I'll quickly do a copy paste and I'll show you the contents once I have the file ready. So here is the code which we have. I'm code here. So this is the for loop which we have. So in the for loop, I have for counter n. There's a mistake there. I should use put CTR. So for CTR n 1 to 5. So let me execute this and let us find out what it gives us. So it is giving me 1 to 5. When I use the double dot, it is going to take me from 1 to 5, inclusive of 1 and 5. There is another form. Let us re-execute this, and it is going up to 4. Let's find out what is it that I did. I used the triple dot. With the triple dot, it is up to but not inclusive of 5. But with the double dot, it is inclusive of 5. Any doubts so far? Any questions? So we have seen the while loop, the until loop, the for loop. I'm going to bring in the break here. If CTR is equal to 5, break end. If CTR is equal to 5, break end. Let's find out what happens when I do this. At 5, it has terminated. Now in case I comment out those lines and look at what is it that I have done, what is it that I have got earlier. This is what I got earlier when I comment out these 3 lines. Again, I'm going to go and remove these comments and re-execute to show you what it is showing you now. So here is your while loop, and this is the code for the while loop which we have executed. We have uncommented it, so it has broken at 5. Observe that we have already displayed put as CTR plus equals 1. After displaying, we are checking if it is 5, so it is going to display it, and then it is going to break out of the loop. Similar to continue, which you have used in C, C++, we have a command called next. The next command is the continue for you. So what I'm doing is I'm quickly modifying the contents. So instead of the break, I'm giving a next. Now I'm executing this. Observe that it is showing you 2, 3, 4, 5, 6, 7, 8, 9, 10. If CTR is equal to 5, we have given next. It is showing you absolutely no difference. Why is it showing you absolutely no difference? We will appreciate it. What I'm going to now do is I'm going to make a small change with the program. Instead of displaying the output before, I'm going to display the output after. So here I have shifted the put as from before if to after if, and I am re-executing this program. When I re-execute the program, I am getting a 2, 3, 4, 5, and it has gone into an endless loop there. Why is that so? Because I am giving next and I am going to the next iteration and the increment has not happened. So what I will do is I will give a CTR plus equals 1 before. I'll give a CTR plus equals 1, that is the increment I will do before, and then let me show you the code for you. This is what the code looks like. I have CTR plus equals 1. If CTR is equal to 5, next, end. So now when I execute, it is showing me 2, 3, 4, 5. It did not display. When I gave if CTR is equal to 5 next, it means it is going to the next iteration. It doesn't do the print which we have, that is the put as CTR, meaning the rest of the statements in the current iteration are not executed. It goes on to the next iteration. So we have seen the while loop, the begin end while, the until, even until supports the begin end until, and we have the for loop. We have also seen the break and next. When you're working with the while loop and the until loop, you can have a number running from 1 to a certain number, whereas when you're working with the for loop, you're working with a list of values. How does it work? Let us look at it. You have seen the range there with for. This is what for looks like. Forward in A, B, C, D, E. Put as word end. Sorry, I was supposed to give the commas there. So comma separated list of values. Okay, my mistake, I'm sorry. So I have not given the quotes here, because if we don't give the quotes, it assumes that this is a variable. It assumes this is a variable. Give me a moment. Allow me a moment. Let me bring up a notepad and do it there. So what we are seeing here is you have the for loop and you have the list of values coming from a range. These list of values could also come from a list of from an array or a list of values which you could have got in a string. When you are doing a double dot, this will translate to 1, 2, 3, 4, 5. Whereas if I give a 1 triple dot 5, it will be 1, 2, 3, 4. When you use double dot, it will be inclusive of the last number. When you use triple dot, it is going to be excluding the last number. Let me just execute that for you so that you recap what you have done. This is the for.rb. So this is with the double dot. Type for.rb. Now I'm going to change it to a triple dot. This is the dot dot here. So it is inclusive of the last number. If I give the triple dot, I've changed it to triple dot here. Observe this. And now it is going to give up to but not inclusive of last number. A up to but not inclusive of the last number. So we have seen how to work with the loops and the conditionals. As I mentioned, the for loop is actually used for a list of values. As it is used for a list of values, you could have the list of values given, which is in the form of an array 2. So we haven't yet seen arrays. We will revisit the for loop when we see arrays, and we'll see another form of the for loop where you can give the list of values at the for loop after the in the for loop. Any doubts or questions? Let's go on to see what we have with the data structures. You have two types of data structures which Ruby offers. One is arrays, the second is hashes. So what we'll do is we will go on to see what we have with the arrays and hashes. Let me get you. Let me quickly get the code for the array. So here is the array. I'm creating an array, and what I do is I give a put as score. I give a put as score. Now what I do is I go and execute this at my prompt. So let us first reconfirm that what we saw on the notepad is the same. And now I'm executing this array.rb, and it shows me 77, 64, 30 and 38. Okay. So now we are able to see the list of values. But note that it is coming as an output of put as score. Now what I will do is I will just give put as score of 1. Let us find out what it gives me with a put as score of 1. It is showing me 64 here. It is showing me 64 here. What does it indicate? Index of the first element is 0. Index of the first element is 0. Because index of the first element is 0, it did not show you 77. It directly went on to display 64 because we have given index as 1. So what I'll do is I will modify this, and I'm going to display a certain set of values from this particular script. So here is the script. I'm giving 0, 1, 2, 3, 4, and let us go on to execute this particular array.rb. It is showing me 77, 64, 30, 38, and it is showing me nothing. Observe that it did not give you an error message. 0 is 77, 1 is 64, 2 is 30, 3 is 38, but 4 does not have any value, but it did not complain. So what we need to understand is, if there is no value, it is not going to bounce off with an error message. It's not going to bounce off with an error message. Now let's go on further to find out what we have with the arrays. You have seen the values as 0, 1, 2, 3, 4, and let's go on to see if we can do something beyond this. Let us see if we can do something beyond this. What does it mean, something beyond this? Let us try and understand. Now what I will do is, I'll give a put s with score of a range. Let us find out if that would work for us. Score of a range. So here I am giving 1.3. Let us find out if it is going to help us. Observe that after score of 4, which showed nothing, it is showing the 1, 2 and 3, which is 64, 30 and 38. 64, 30 and 38. Any doubts here? Any questions? So we can choose to see a range of values. We can choose to see a range of values. If you do not want a range of values, let us find out if it is going to help us in just showing different values which we need. Observe this. It is showing 64, 30, 38. Let us find out what are the contents of the file. I have given 1, 3. From 1 to 3 can be indicated either as 1.3 or 1, 3. Now I am going to further modify this, and what I am doing is I am going to display something here, that is I am giving a -3. So let's find out what it gives when I give a -3. It is giving 64. Now we will change this to -1, -2, -3, -4 to find out what it is going to give us. So I am giving a -1, -2, -3, -4, saving it. I am showing you the code now. This is what the code looks like. -1, -2, -3, -4, and now I am showing you the execution. It is showing me 38, 30, 64, 77. 38, 30, 64, 77. So it is giving you in the reverse order. The index of the last element of the array in Ruby is -1. That of the previous is -2, then -3, -4, and so on. Any doubts, any questions? Okay, so let us find out what it gives us, but I'm just scrolling up to show you if we saw the value or otherwise. So here is a 1, 3. So this is the execution, array.rb. It shows 64, 30, 38, and then I showed you type array.rb and it showed me 1, 3. Okay, so it was actually showing you 1, 2 and 3. I mentioned that when you give 1.3 or 1, 3, the behavior is the same. What I will do is, just for your benefit, I will again bring in that. Just give me a moment. Let me show you the modification which I am doing so that you are with me. So here is my notepad, commenting this. What I do is I give 1, 3. I'm not doing .3. I'm doing a directly 1, 3. So let me get you the session for you, and in the session let me give type of array dot. So all that is commented, I just have a 1, 3, This is what 1 comma 3 gives you, 64, 30, 38. Okay. So let's proceed. So we have seen we are working with arrays. We are working with arrays. Let us see what we have with arrays. With arrays, we have seen how to work with uh, a complete array by giving the name of the array. How to work with individual elements, both with positive as well as negative indices. Both with positive as well as negative indices. Let me make a small modification and find out what happens when we are doing it. So let me get your array.rb. Now what I do is I give a -1, 1 and let us find out what it is going to show us when I have a -1, 1. So here is the code and here is the execution. The earlier code was 1 comma 3, it showed you 64, 30, 38 and then it just gave 38. Where is 38? 38 is the -1. 38 is the -1. You have given 38 -1 comma 1. So it is just giving you what we need to understand when you are giving a range like this with the array is it is going from left to right. Because it is going from left to right, when you give the rightmost element index first, it just displayed that. Because the next value which you have given is coming to the left, I can't display anything else, so I have stopped. I'm making a small modification here, and now what I will do is I will show you the contents. I've given a 2 comma 1 and I'm executing. Observe that earlier it had given 38 for a -1 comma 1. Now it is giving 30 for -2 comma 1. It is not showing anything else. It is just showing you -2. But if instead of this I modify this and get a -4, what will happen we will see. This is a -4 comma 1 and this is what it is giving me. It is giving me -4 comma 1. -4 is actually the first element. It is actually the first element, that is 77, and it is giving you just that one element there. So what we are seeing here is it is showing you the indices. It is best that you work with positive indices. Negative indices are available, you should know, but it is best that you avoid using. Why is it that I'm showing you the negative indices if I want you to avoid using it? That's because if you're working with a loop and you happen to have a number going from the maximum value downwards, as long as the value exists, I want to keep showing the value. In such a case, instead of displaying it once, I will display it twice, because I will start with 3, 2, 1, 0, -1, -2, -3. So that's the reason why it is best that you use only positive numbers, positive indices, not negative indices. But you should know that negative indices exist. Any doubts so far? Any questions? Any doubts or questions? Let us see it on the system. Let me get you your terminal where it is getting executed. So the question we had was -1 comma -4, right? Or -4 comma -1. -1 comma -4. Okay, so I will make the modification here. -1 comma -4. Let me show you the modified code. So this is -1 -4. This is what it will give you. Observe, this is 1 comma 3, that's the 64, 30, 38. -1 comma -4, it actually showed you nothing. Why is that so? Let's try and understand. This is your -1, -2, -3, -4. This is your -1. This is your -4. It showed you nothing. If you had given -4 comma -1 or 1 comma 4, it would make better sense showing from left to right. Ideally what we assume is, if I give indices in the reverse order, it is going to show me from right to left. It doesn't happen that way. It shows you from left to right only. If there's nothing on the right, I don't show you anything. That's what Ruby does. We have worked with arrays. Now the question is, I have scores, and in the score I have 77, 64, 30 and 38. 77, 64, 30 and 38. Whose score is 77, whose score is 64, whose score is 30 and whose score is 38? Any answers? By the way, these are cricket scores. No, my question is, whose scores were this? Because this was a very recent match. Even though it is a recent match, which is just about 3 days away, if not more, we are not able to recall whose score was 77, whose was 64. 77 was Chris Gayle, Virat Kohli. Yes, you recall because I told you it is a recent match. Okay, but ideally we know that we don't recall who is 0, 1, 2, 3 when you just give us the scores. A match which was played less than 3 days away, we are not able to recall the players' names. What if I give you the score which was maybe of a match which was played 5 years back? Now it would be next to impossible to recall unless and until you are a genius when it comes to cricket scores. So now the question is, when you're working with arrays, it may be comfortable in a few situations, but it is not comfortable in all the situations. You would rather want to have a key value pair, as in a hash, as compared to an indexed array. When you're having an associative array, which is also referred to as a hash, what it does is, instead of having the number as an index, it will have a key, a name, if you will. So what we will do is, we will go on to create a hash.rb. We'll create a hash.rb, and let's go on to create. Let me get you the code on the screen of hash.rb. And let me do some copy paste. I have the code ready for you. So here is the code. So it was Chris, Virat, Head and Kedar who had these numbers. Those were the scores of those 4 players. But now we need to actually get the scores on the screen. So what I'll do is I will display the scores.keys, the scores.values, and the scores.each. Let us save this. Let us go to the terminal to execute this. So here is your terminal, and if I'm executing this, let me first show you the contents. These are the contents, and this is the execution. So here when you execute, let us find out what it is giving you. Chris, Virat, Head, Kedar, then it is showing you the values. With the scores.each, it is giving me an enumerator. But what it does is, when I'm running through with a loop, this will actually give me key value pairs. It will give me key value pairs. It will give me both, each. It will give me key value pairs. We'll see that very shortly. We'll see that when we see the code. So what we will do is, we will go ahead and get to work with the scores.each. We'll work with scores.each. Something wrong. Let us see the scores.each. What do you see? What screen are you seeing? The terminal? Okay, it has not changed. Okay, because I tried to change something and it was not responding. That's why I thought I'll check with you what is it that you're seeing. So now what I'll do is, I will show you the contents of the hash. Let me show you the contents of the hash. So these are the contents of the hash. Scores.each, do key comma value, print key scored value, print key scored value. So now what I will do is, I will execute this particular program and let us find out what it gives us. It is giving me Chris scored 77, Virat scored 64, Head scored 30, Kedar scored 38. Okay. Any doubts, any questions? Are we online? Hello? Hello? Yeah, actually by mistake I had got disconnected, so I got back immediately. Okay. Yeah, that is only a fluke. Whether it is working with Ruby or any other programming language, it is not supposed to retain the order. It is not supposed to retain the order because depending on whenever you created your value, that is when you add a new value to your existing hash, wherever the space is available, it is going to do the fill up the blank kind of stuff. So if it is an ongoing, if my operating system is extensively used, then I may not really see this kind of result. If you are working on a Unix server which is used by multiple users, you may not get to see this kind of a result. People who have worked with other programming languages like Perl or Python or Visual Basic, where it is called as collections there, or TCL, in associative arrays, we see that it is not supposed to retain the order. Let's move on. You would like to have a break? Okay, we can take a break here. We will come back in 15 minutes. Okay? Yeah. Yeah. Thank you very much. ಜ್ಯೋತಿ ಖಲೀಲ್ ಕಳಿಸಿಮ್ಮ, ನಾನು ನೋಡ್ತೀನಿ. ನನಗೆ ಗೊತ್ತಲ್ಲ. ಹೌದಾ? ನೀವು ಕಳಿಸಿ, ನಾನು ನೋಡ್ತೀನಿ. ಎಲ್ಲ ಕತೆ ಅದು, ಎಲ್ಲ ಕತೆ. ಎಲ್ಲರೂ ಹೇಳ್ತಾರೆ ಬೇಸಿಕ್ ಗೊತ್ತು ಅಂತೇಳಿ. ಯಾಕಂದ್ರೆ ಬೇಸಿಕ್ ಹೇಳ್ಕೊಡ್ತಾನೆ, ಅಡ್ವಾನ್ಸ್ ಹೇಳ್ಕೊಡ್ತಾನೆ ಟ್ರೈನರ್ ಬಂದ್ರೆ ಅಂತ ಗೊತ್ತು ಅವ್ರಿಗೆ. ಎಲ್ಲ ಹಳೆ ಕತೆ ಇದು. ಕಳ್ಸಿ. ಓಕೆ ಮಾ, ನೋ ಪ್ರಾಬ್ಲಮ್. Welcome back. Are you able to see the screen? Okay, okay, right. So let us go on to see the command prompt. So just before the break, when I was exploring the for loop, I made a few mistakes with the for loop. So let's see the actual syntax of the for loop when you want to process a list of values. For word in, let's say A, comma B, comma C, put as word end. So this gives you the list of values. So you can process the list of values like this. So this, what you're seeing, is actually a processing of an array. We had actually started off discussing the associative array or the hash, and we also saw an example of working with hash. So this is the piece of code which we saw, and this is the execution of the code. This is the execution of the code. So let's move on to take the next step. Let's go on to see what we have with working with files. When you're working with files, you have the open, read, write, close. Those are the commands which you have in Ruby. And we will go on to see a couple of examples to quickly understand how to work with it. But before we go on to explore working with files, let us look at one additional piece of code. And this piece of code which we will be seeing will be with respect to processing command line parameters. We'll be looking at command line parameters. To work with command line parameters, first of all, let us create, let's say, params.rb, and let me share the params.rb with you. So this is the params.rb where I'm going to be writing parameters. So I'm just giving a put as argv. Let us find out what this does. Just giving a put as argv, and let me show you the code here. And I'm giving params.rb space. These are the parameters. So it is showing me these are the parameters. So this is what we have in the argv. Now what I will do is I will modify the argv, and I'm doing something and re-executing the same command. It says these. Let me show you the contents of the file. Excuse me. So these are the contents of the file. RP is an array for you. In that that array, whatever are the command line parameters you enter, those are going to be available inside the Ruby script. So once it is available inside the Ruby script, you will be in a position to use these from inside your script. So now what we will do is, I'm going to be working with command line parameters. First of all, I will show you a piece of code using which we can display the contents of the file on the screen. That is nothing but your cat command on Unix operating system. Okay, let me create it is type.rb. So I have this file called type.rb. All that I have is open argv of 0. That's the argv of 0 which we have seen earlier. And then you are reading from the file handle and displaying the contents on the screen with one single statement. So you're doing a print and you're displaying the entire content. So now what I do is I do a type.rb space type.rb, and this is what it is giving me. Type.rb space type.rb. Let's say I give params.rb. So this is related to parameter processing, what you saw. This is the actual content of the type.rb. You use the open function. Open file name. The file name I'm using command line parameter, and I'm indicating that I want to open the file in the read mode. And then I'm reading the contents and I'm displaying it onto the screen. Let me modify the contents of type.rb, and in the modification what I do is I'm going to split that line into two. I'm going to split the line into two. So I give I'm executing that here. This is what I have. I have split it into two. Lines is equal to file handle dot read, and then I'm doing a print lines. Earlier we had a shortcut notation. Directly we are doing a print. Now what we will do is we will further modify this and find out what is the class to which this particular lines which we have created, this particular object which we have created, what does it belong to? So I'm giving type.rb to see that I have a dot class there. So it is going to give me in the form of a string. So entire list of lines what I have, they are available to me in the form of a string. So let's move ahead. So this was the type function where we are able to see the contents of the file on the screen. Let's go on to take the next step. Let us see how to open the file in the read mode as well as another file in the write mode. This is the file which is open in the read mode. We will go on to open the file in the write mode. After opening the file in the write mode, we will read from the first file and write to the second file, meaning we will implement the copy command. So here is my copy.rb. So what I'm doing is I am opening the first file in the read mode, the second in the write mode, reading from the first file and writing to the second file, and then I'm closing both the file handles. Let's find out if this is going to work. Copy.rb. I will copy the same file, copy.rb, and let me call it as new copy.rb. So So let us give dir new copy.rb, it is showing me, and I give a dir copy.rb, and you'll see that that is also showing me 110 bytes. So when I give type new copy.rb, it is showing me this data. I give delete new copy.rb, doesn't exist, re-execute, see the contents, and I see the contents of that file. So we know that we can work with files when we are working with Ruby. These are flat files. Whatever you have done with flat files with other programming languages, whether you are opening the file in the read mode, write mode, append mode, uh, read write mode, whether you are reading from the file, writing to the file, you are repositioning the file pointer using the seek, all that is permitted when you're working with your Ruby. Ruby allows you to work with all this. Let's move on to see what we have with exception handling. Without exception handling, the program would crash, and when the program crashes at the client side, that's when it is referred to as a customer found defect. And we know that whenever there is a customer found defect, you will have an excited manager, right? Is there anyone online? Hello? Okay. Okay. So we will go on to see how to work with exception handling. If you do not have exception handling and the program crashes, then we know that if the code crashes, then it is going to give you a customer found defect, and the customer would complain about a crashed application. So let's go on to see how we can work with exception handling. Let's go on to see exception handling. I have a program already created to see what exception handling we have. So I'm opening that program. So here is the code. I have a x is equal to 10. Begin. This is the begin block. It is with the begin block that the code starts, and what you have with the begin block is the code which has to be executed. After that, you have the rest of the code, and there is an end at the bottom. Immediately after begin, you have the code to be executed. Then you have the list of possible exceptions. The list of possible exceptions. So what I'm doing is, I'm just showing you a couple of exceptions here. One is the zero division error. So now what I'm doing is, I'm giving y is equal to 0. I'm saving this program. saving this program, and what I do is I show you the execution now. So here comes your here's the code. X is 10, Y is 0. So we know that it should give you a zero division error. Let us see the zero division error here. You cannot divide any number by 0. And then observe that at the bottom there is a block called ensure, where it says this gets executed always. This gets executed always. Now what I will do is I will create another file. I will create another file, and in this file what I am doing is I am on purpose just having a divide by 0. I have a 10 divided by 0, that's all I am going to have. I'm going to have a 10 divided by 0, and after this I am showing you the contents of this particular file, and I am executing this particular file just to see the error message. It says divided by 0, zero division error. Divided by 0, zero division error. Now in this case, if I have any other line of code after this, that does not get executed. Let's say I am giving a put as 10 after this, and I am going to show you the put as 10 which is here. Observe that put as 10 is here, but when I execute this, it is not showing you that put as statement, it is just terminating the program and coming back. So this is what happens when there is a program crash. But when you have exception handling implemented, as in the case of this particular program, even though you have a zero division error, it gave you you cannot divide any number by 0, and it came back. Now what if instead of having a zero division error, what if the name of that variable did not exist? Let's say I have a x divided by y, either x or y did not exist. What would happen? So what we will do is we will make a small modification here. So we are going to have x divided by, instead of y, I will give, let us say, q. I'll give a x divided by q. And now what I do is when I execute this, observe that it is giving you exception class name error. Where is it coming from? Observe that instead of just a put as, I have 3 different put as's here. You have name error, you have an arrow E to indicate, treat that as a shortcut, as a alias. That's what you're doing. You could have given name error dot class name error dot message, name error dot backtrace. Instead, what you're doing is you're just using that word E for exception. This is the exception dot class dot name is what you want to see, and then you have the exception dot message, exception dot backtrace. In other programming languages, we have the concept of try and catch. Here you have a begin and rescue. Try and catch is actually begin and rescue here. And in this case, because that exception has a name, that name is what you want to gather. You're doing a e.class.name, and if you look at it, it says name error, and then you have a e.message, it says undefined local variable or method q. Why is it complaining? You want to know. So you want to get the message, and then you are getting a backtrace. You are getting a backtrace. You are getting the information as to what is it that happened due to which it is giving you the error. So it is giving you the line number where the termination happened. And finally you have that line which says this gets executed always. Now let us say, for example, you're working with sockets or you're working with databases. In such a case, what happens is After the exception, you do not want that database to be open or that socket to be left unclosed. So you want to close it, and that's what you're going to do in the ensure. So if I'm working with something like a database or a socket, I'm going to open it in the begin or maybe outside too. I'm going to work with whatever that object is supposed to be. In case of any errors, I do not want to leave that object open. I want to close it. That's what I'm going to do with ensure. Now between the begin, rescue, ensure and end, there is also one more, and that is else. When you're working with any application, you have a set of possible exceptions which you are working with. Let us say, for example, in case you find that after having listed the possible exceptions which you are expecting, you want to make sure that in case of any other exception which you are not able to anticipate at this point, what should I do? You do not want your application to crash, due to which you are giving an else there. This is the case else, or in case of any other exception, what should I do? And that's what you're doing. There was an exception. In case there's any other exception, then it is going to show you this particular error message. So now what I'll do is I'm going to go to this particular file and I'm going to modify this file, and I'm going to remove that zero division error. I'm going to comment out the zero division error. So here is what it looks like. I have commented out the zero division error, as well as I have given the x divided by 0. Now that I have given the x divided by 0, what I do is I'm going to re-execute, and here is what it is giving you. This gets executed always. Something wrong. I was expecting the else to be executed, but something. Give me a moment. Ideally else was to be executed, but for some reason it's not getting executed. Not sure what is the reason at this point. So I'll check out what's the reason. Maybe I'll come back on that. So here is what I have. What we have just seen is we will be in a position to do exception handling. So you can handle multiple exceptions, and you could also handle default exceptions. And after the exception is handled, if you have anything else to be executed, that also you can take care. That is what we are referring to with the ensure. Okay, so let's move on. Any doubts so far? Any questions? So let's move on to the next topic. The next topic we explore is object-oriented programming. Object-oriented programming. Ruby is a purely object-oriented programming language. When I say Ruby is a purely object-oriented programming language, Ruby treats everything either as a class or as an object. So what we will do is I will just show you one example here. When I say Ruby is a purely object-oriented programming language. We know that when I have an object x is equal to 10, I can give a x dot class to find out to which class this object belongs. What if I have a 10 in this form and I give a dot class here? I'll be in a position to find out what is the class to which this object belongs. Even this value I can find out what is the class to which it belongs, or this value to which class does this value belong. So when you're working with Ruby, everything is an object or a class. If you're new to object-oriented programming, okay, how many of you have never worked on object-oriented programming? Anyone here who has never worked on object-oriented programming? Okay, so everyone has worked on object-oriented programming. So let us quickly look at what are the concepts which we have in object-oriented programming. We have the concept of a class and an object. When you talk about the class is nothing but a blueprint. That is what you are declaring. This is what the object is going to have whenever I create an object of the class. And then when you are creating an object, the object would have the same attributes and methods whatever you have defined in the class. An attribute is a variable and a method is a function in that particular class. Now let's move on to see what we have with classes and objects. So I have this particular file called, so what I'll do is I'll just modify this file. Let me show you the contents of the file. Just give me 2 minutes, I have too many files open. I'd like to close a few of them. It's actually taking some time from me, so let me do some cleanup quickly. Okay, so let's go on to see what we have with this particular file. In this file, what I'll do is I will start off with just going to comment this okay, then end. I have too many ends there, so there's a possibility that this guy is going to give me some trouble. Okay, so what I'll do is I am going to remove some code from here. I'm going to remove some code from here, and I save this program and I comment a couple of lines here, and allow me a minute. Let me just save whatever I've cut from there so that I don't lose that. So here is what I have. Class infant, this is what I have. So this is my class which I have. It has class infant, defined initialize, put as cry, end. I'm not going to explore too many things with respect to object-oriented programming in the interest of time. because it has really too many things, as we are aware, when it comes to object-oriented programming. So I'm going to just touch upon a few things. I'm just touching upon the constructor here. Constructor is called initialize. It is nothing but a function for us. Define function name, and I have put as cry. So that's the infant. So when I execute this, the object is created by giving the class name .new. Object is created by giving class name .new. So when you give a .new, it is the initialize method which is executed, and the code inside the initialize method gets executed there. So now what I do is, I go on to show you what we have with the concept of inheritance. So with inheritance, what we are going to see is, we are going to see a class called mom, and this class called mom, which we have, is we are inheriting from a class called mom. So now I have this particular piece of code where I have a class called mom, and this is how you're going to indicate inheritance. In the class called mom, I have a method called walk. So if I do not have this connection, if I do the disconnection here, just a moment, if I do not have this connection here between the base class and the derived class, and if I happen to execute this piece of code, if I happen to execute this piece of code, it is giving me undefined method at line 19. At line 19. So what I'm doing is, I'm just commenting out the last line here and re-execute. It's still saying 19, which means that the last line was not 19, it was 20. So now I commented that and it gave me cry. Now I'm going to have a connection established between the base class and the derived class. When I see the connection between the base class and the derived class, now I have the less than mom here to indicate that there is a connection between the base class and the derived class. I will also remove the comments on those two lines, last two lines, and then execute this. Let's find out what's the error message. It says line number 19, there is an error. So what I do is, I comment out a line there and re-execute. It says walk elegantly. Walk elegantly. Where did that come from? Let us try and understand. So here is where it is giving you walk elegantly, and that is coming from the base class. That is coming from the base class. Any doubts so far? Any questions? So let's move on. So you have seen that there is a connectivity between the base class and the derived class. The infant, class infant, is going to inherit from the base class mom, and this is how you are going to indicate inheritance. You can create, when we saw the variables in one of the first few slides, when we saw variables, we saw that we could have instance variables and you could have class variables. Instance variables are created using the @, class variables are created using double @. If you do not have any symbol before the name of the variable, then it is going to be a local variable, and in case you have a dollar at the beginning, then it is a global variable. So we have just seen couple of things when we come to object-oriented programming. We've just seen how to create a class, and we saw how to create an object, and we saw inheritance. So this is what we have seen with respect to classes and objects. When you're working with databases, Ruby offers access to a variety of databases. You can work with ActiveX data objects, you can work with IBM DB2, you can work with Frontbase, MSQL, MySQL, ODBC, Oracle. From Oracle you have OCI8, you have PostgreSQL, you have Proxy Server, SQLite, SQRelay. It offers a host of them. How does it work? Let us look at the database access at the architecture level. So what we see is, at the base you have the RDBMS, which is at the bottom of the list. So that's where the data is actually stored. For you to access the database from the database server, you need what we call as a DBD, that is the database driver. Historically, when you look at other programming languages, if you had to access a database, what used to happen was you had to request for an extension of the programming language from the organization, from the vendor who developed the database server. For example, if you have to be working with Oracle, you had to request Oracle to give you an extension of the programming language of your choice. Like for example, if you had to work with Oracle and Perl, you had to request Oracle to give you Ora Perl, which would be an extension of Perl which was suitable to work with Oracle. Now, in case you move from one database server to another database server, you would have challenges. And that is, if let's say I'm moving from Oracle to DB2, then the challenge I would have is I would need to rewrite the code, because the code which I have written for Oracle is using the extension of the programming language supplied by Oracle. Similarly, when I'm working with DB2, I will have to request IBM to give me an extension, and I have to have that particular syntax. But with the coming in of DBI, what happened was a lot of standardization came into picture. DBI is being used very extensively in all programming languages, inclusive of Python, Perl, Ruby, and so on. Now, when you're working with DBI, that is the database interface. Now, when you're working with any RDBMS, you have two things. One is the SQL, which is the standard SQL or ANSI SQL as we know it. And the second is the extension of SQL. Excuse me. When you're talking of the extension of SQL, what are we referring to? If you work with Oracle, you work with PL SQL, that is an extension of Oracle, an extension of SQL given to you by Oracle. SQL does not have the conditionals and loops. PL SQL gives you the conditionals and loops, the programming constructs. Similarly, if you're working with Sybase, Sybase offers the support to SQL and also offers another extension of SQL which is called as TSQL or Transact SQL. So when you're working with Transact SQL, you'll find that Transact SQL is not only available with Sybase, it is also available with MS SQL Server. The reason being, MS SQL Server was actually developed by a team of Sybase developers. So we see that it is the same Transact SQL which is available in both Sybase and MS SQL Server. So when you're working with the standard SQL, whatever standard SQL you're using, that will be available in your DBI. You have commands using which you can execute the SQL code. When you're working with DBI, what do you see? You see that you are going to have statements, SQL statements which you execute. Either it returns some data or it returns no data. So when you're working with the DBD, what the DBD is doing, the database driver is doing is, it is doing the liaising job between the actual RDBMS server and the DBI. And if it is something to do with Oracle, it is going to be the DBD of Oracle which takes over the command. If it is something to do with MySQL, it is going to be the DBD of MySQL. Similarly, whatever is the low-lying database which you're using, low-lying RDBMS you're using, that the database driver for that particular RDBMS is going to do the job. Any doubts here? Any questions? So when you're working with Ruby, you have the require keyword which is used to load a particular module. So we'll be loading a module which is related to the DBI. So you'll give require in quotes DBI to load the DBI module, and then you're going to do a require DBD Oracle to work with the Oracle server. And then you have code which is supported by the DBI and the DBD which you're going to be executing. And when you're working with any RDBMS server, you're going to first connect to the database. After you connect to the database, you are going to execute the command, whatever SQL statements you have. Either the SQL statements return something or they return nothing. When it returns something, then you can actually work with whatever they have returned. So if you are querying what are the number of users who have a certain value in their job profile, then you'll get all those list of values and you can process the data which is returned. When it returns more than one value, you use what is referred to as a cursor. When you're working with multiple values, these multiple values will be stored in the memory. It will be more like a table which will be stored in the memory, and the cursor will be pointing to the current record, and you can read one line at a time or one record at a time and process all the records. Let's move on to CGI scripting. When you're working with CGI scripting, what we are looking at is, we are looking at a HTTP server, and the CGI script which you are going to write is with respect to a certain HTTP server. Let us try and understand what is it that you have with the HTTP server. The HTTP server, let us say for example you have your Apache server or any of the HTTP servers. You give http:// followed by the IP address of the server or the DNS name. So whatever is the URL which you have, you give that, and this is going to show you the screen which is going to be coming from a file which is sitting on the server. Now when this file comes up on the server, what happens is, this may be just a text file, a static file, or it may be a form. If it is just a text file which it is displaying, it will most probably be a HTML file which is going to be displayed. HTML uses tags to do the formatting. You can display the data, the text in bold or italics or in a certain list form, maybe in the form of a list or a list of numbers or bullets. You can have radio boxes, check boxes and so on. the form, whatever you're creating in HTML, you'll be in a position to create it on the HTTP server. Now, when you see the form, you fill up the form, and after you fill up the form, you are going to hit the submit button. You are going to click the submit button. When you click the submit button, what happens is whatever you have keyed in, this is going to be transferred to the HTTP server. When it is transferred to the HTTP server, in the HTML page itself, in the form itself, you have indicated who is going to be doing the processing of the data which is going to be sent from the HTML form. So when the data is sent, because it is indicated in the HTML page itself who is going to be processing the script, which is the script which is going to be processing the data, the script is going to come up and it is going to do the execution. It is going to take all the data which has been sent from the HTML page, it is going to do the processing, and in case it has to return something, it is going to return that, and it is going to be displayed on the screen. Now let us try and understand what goes into a CGI script. What is the qualification for a programming language to be qualified to be processing processing the data coming from the HTML. All that the programming language should be able to do is read from the keyboard and write to the monitor. Read from the keyboard and write to the monitor. Now the question is, why is it that some programming languages are popular when it comes to CGI scripting and some programming languages are not so popular when it comes to CGI scripting? Some programming languages are popular when it comes to CGI scripting because they are very strong working with regular expressions. In fact, even Ruby is popular as CGI scripting language. You could use regular expressions when you're working with Ruby. So when you're working with regular expressions, now the question is, why would you need regular expressions? Because when the data is sent from the form, from the HTML file, whatever form you filled up, that data is not going to be sent as it is going to be encrypted and sent. That encryption, whatever it does, you will need to do the decrypting at the script level. After you do the decrypting, you are supposed to use the data, process it, and if there is something which has to be sent back to the client, then it is going to be just writing it onto the screen, and that is going to be displayed on the client machine. Whenever you're working with CGI scripting, what you need to understand is, in CGI scripting, the script which you're executing, the file in which, in case you're storing any data, that file should have write permissions not just for user and group, it should have write for others. The read and execute permissions, in case you want to execute the script, should be given to the others. The first question is why? Because when you are executing your program, your CGI script, you are not executing as the user you have logged in locally. You will be executing that as a third person, not a person working on your system. Even though your web browser was open in your system, it is not going to be executed with that privileges. It is going to be with the other's privilege that it should be executed. Any doubts here? Any questions? Let's move on to the next topic. The next topic we explore is socket programming. Now when you're working with socket programming is supported by Ruby. Ruby offers the complete set of functions, methods which are available when you're working with sockets. So let me just share a screen with you. Just a moment. I'll just bring up a notepad. So I'm bringing up this notepad here called sockets.rb. So let's find out what we have with sockets. When you're working with sockets, in case you've worked with socket programming on Unix or Windows or any other platform, you would have observed that the socket programs have a certain way to work. You have a certain way to work. When you're working with socket programming can be used for two things. One is inter-process communication, meaning socket programming where the two sockets, the server and the client, are on the same box, which is the example I'm going to be showing you now. And the second option is you could have network programming where the two boxes, the two applications, the client application and the server application, are residing on two different boxes altogether. In such a case where the two boxes are not on the same system, then that is when you are going to call that as network programming. When you're working with socket programming, you have two types of sockets which you create. One is Unix sockets, the other is iNet sockets. Unix sockets are used for inter-process communication and iNet sockets are used for network programming. Apart from this, you also have two types of sockets. One is the datagram socket, the other is the stream socket. When you're working with datagram socket, what are you talking about? You're talking of working with UDP/IP. And when you're working with stream sockets, you're working with TCP/IP. When you're working with UDP and IP, both these protocols are connectionless, unreliable protocols, whereas TCP is connection-oriented, reliable protocol. Now, why is that so called as reliable? And why is it that UDP and IP are referred to as unreliable? Both UDP and IP are going to pick up the packet coming from the upper layer. They are going to put their header and footer, and they are going to hand it over to the lower lying layer and consider their job done. Whereas TCP is not like that. It is going to put its header and footer, and after that what it does is it takes care of two things. One is it starts a timer and it starts a counter. When it starts the counter and the timer, it sends the packet to the lower lying layer, but then it is expecting an acknowledgement from the destination TCP layer. When the acknowledgement comes from the destination TCP layer, then it is going to send the next packet. Till then, the packets are queued. When you're working with TCP, it is going to send the packet and decrement the counter and start the timer. When the timer lapses and if it has not received the acknowledgement from the destination, it is going to send the next packet, retransmit the same packet again. It's only when it gets an acknowledgement does it send the next packet. So that's the reason why TCP is referred to as reliable and UDP and IP are referred to as unreliable. When you're working with socket programming, you have two things which you'll look at. One is working with stream sockets. The second is working with datagram sockets. If you're working with datagram sockets, it's more of a point-to-point communication, whereas stream sockets, you'll see that it is more like a client-server setup. So let us look at the stream socket setup. First of all, you're going to create a socket. After you create a socket, what you do is you execute a system call which is called as bind. What does bind do? Socket is just creating a communication endpoint, whereas bind is giving a name to that communication endpoint. When you're working with stream sockets, we have what is called as a listener. So when you're talking of a listener, this is the listen system call which is going to mark the socket as a listener socket. When the socket is marked as a listener socket, there is a backlog which is indicated. What is this supposed to be? This is the number of connections which can be in the queue, which can be in the wait whenever one connection request is being processed. After the listen, we have the accept system call. What does the accept system call do? the accept system call creates a new socket. It is using this new socket that communication happens with the client, which means you can have multiple clients connected to the server and you can have communication. After this, yes sir. Are you seeing the notepad? Are you seeing the notepad? Is it now is it showing you the whole thing? Now it is showing you the whole thing. Okay, thank you very much for the feedback. Okay, so when you're working with stream sockets, you have the listen, which is going to mark the socket as a listener socket. So you can have multiple socket connection requests coming in, and one of them is being processed. The backlog indicates how many can be in the queue. Then you have the accept system call, which will mark this socket as a listener. The accept system call is going to create a new socket, and whatever new socket you have, it is using this new socket that you are going to have communication. You are going to do a read and write on the server side. So this, what we have seen, is the server. On the client side, what we see is, on the client side you have the socket, but you do not have the bind, because you are not going to be waiting for, you do not want a constant address, you just want to send a request. So here what you have is, you have a connect. This connection request is going to be sending a request to this particular listener. It is going to send this request to the listen. Once it accepts it, what does it do? It will write whatever it writes here. It is being read by this particular process, and whatever response it has to give, that is going to be read by this particular process. So this is how the communication completes. Now this is when you are working with a client server connection. In this session, I'm going to show you a very simplified version of a client server which can be implemented on your system using Ruby. So let me bring up share the session with you. Here is my socket server, socket-server.rb. Require socket gets the sockets from standard lib. Then you have server is equal to TCP server.open of 2000, that is the port number 2000 we are talking about. And then we have a loop. In the loop, what are we doing? Client is equal to server.accept, and then you have the putS and close. Client.putS, not just a putS, client.putS. So where are you getting the client from? Client is equal to server.accept is what you have given. Now let me share the client code with you, and here is the client code. In the client code, what are we doing? Require socket, s is equal to tcp socket.new, localhost, 2000. Observe that on top you have tcp server.open of 2000, and here I have localhost, 2000. 2000 is the port number, so it is the same port number which we are using. After this, what are we doing? We are giving while line is equal to s.getS. S is the socket, socket.getS. Whatever line you have read, just display it. As long as there is data, keep displaying. Once your job is done, give a s.close, close the socket. So now what I will do is, so far I had been sharing just certain applications. Now I will make sure that there are two sessions which are open parallelly, and I will share my system, and I'll show you both the server and the client running parallelly. I'll show you both server and client running parallelly. So here comes one session. Let me bring up the other session too. Just give me a moment. So this is my second session. In this second session, what I do is I bring this second session here. I bring this second session here, and I have the session here. Okay. So now what I do is I'm going to run the client on one system. One moment. Sulaiman, Milan, door close करके जाओ please. Sorry. So let me get the two sessions on the screen before there's something. Okay, I think I'll share the complete system and then it'll be okay. My screen. Are you able to see the entire screen now? You're not seeing the screen? What are you seeing? Only question mark. Oh, okay. Did it change now? I'm sharing the desktop, but I wonder why you're seeing only application. I'm sharing. Oh, you're able to see two screens, left and right? Okay. Okay, I actually shared that about 5 minutes back. Looks like there was a delay. Okay, no problem. So on the left side, I'm going to show you the server, and on the right side, I'm going to show you the client. So this is the socket time server. So this is the server executing. Note that the server is executing and it's doing nothing. So now I'm executing the client on this side, and it says Thursday, April 20, 17/20/35, 2017, closing the connection by. I re-execute this. Again, it gives me the same thing, just that between then and now there have been 11 seconds difference. So the server is running here and the client is running here. Okay? So now I'll show you the server and the client again, the code of server and client. Let me see if I have the code ready. Let me bring up the code for you. So this is the client code, and here is the server code. So this is my server and this is my client. So here it says server is equal to TCP server open 2000, and then I have a loop which is an endless loop. Okay, and in the loop what am I doing? I'm only working with this particular line, that is server.accept client is equal to server.accept client.put as. So it is the server.accept which is giving me the client socket, and then I'm giving time.now.ctime, and that is what showed you the time in this form, Thursday, April 20, followed by the hour, minute, seconds, and the year. and then you have the closing connection by, and that is the connection by. That's the string which we have given here in the loop, which is being displayed here. And what is there in the client? The client is reading all the lines and displaying all the lines from the socket, that is TCP socket.new localhost 2000. So this is your 2000, which is the port number 2000. Any doubts, any questions? So this was a simple client server program which we've seen. As long as the server is running, I re-execute this any number of times, I'm going to see the output. But in case I terminate this and then I go and re-execute, it is waiting on the port 2000, and once it does not get anything, it comes back. Okay? So that's a simple example of socket programming. So let's go on to see what you have next. You have XML parsing. When you're working with XML parsing, Ruby offers both SAX-like and DOM-like interfaces. For you to be working with this, you will have to have the appropriate modules downloaded. Since morning, the server which hosts the module seems to be down. So I tried to do the configuration this morning, but then it did not allow me. So it did not download the complete module. It bounced off with an error indicating that the server is not up and running. I was not able to get to the mirror, so I am not in a position that I can give you an example of this. When you're working with XML, XML is very similar to HTML, just that instead of using the tags to indicate the head and the body and the form, all this stuff, you have the tag which indicates, you are using tags to indicate a complete database or a record structure, and you'll be in the position to work with XML records. Let's see what we have with multi-threading. When you are working with multi-threading, what are you looking for? Let us try and understand. When you're working with multi-threading, yes, right. When you're working with multi-threading, yes, what you said is right. You can run concurrently. Historically, even though we used to call that as multi-threaded application, but then it was not a multi-threaded application because we only used to have single core CPUs. And of course, some servers we used to have SMP servers where you used to have multiple processors. But with the coming in of multi-core processors, the actual taste of having a multi-threaded server and a multi-threaded client is visible, where instead of using 10 minutes to process 10 records, I am able to see that in 1 minute the 10 records have been processed. Just that it is being processed on 10 different cores. 10 different threads are being executed parallelly, and it is working fine. When you're working with multi-threaded programming, we need to understand the rule here. The rule is, I should have an equation like A plus B plus C, where A is independent of B and B is independent of C, meaning the three components should be independent. Any number of components you have, they should be independent. Here, an A and a B and a C and whatever number of components you have will be implemented in the form of a function, and each function will be executed in a separate thread. Now let's move on to see what we have with multi-threading. So here I have a program ready with me to see an implementation of multi-threading. When you're working with multi-threading, what is it that you're doing? Let us try and understand. First of all, when you're working with multi-threading, you have one main thread which is already there with you, which is whatever program you're executing, it is going to be executed in a process, and that process will have its own thread. When you have only one thread, you don't call it as a threaded program, you just call it as a process. When you create a second thread, that is when the next list of threads you are creating. When you're working with standard Unix operating system, a thread is implemented as a thread, meaning it is inside the current process that you will have a thread implemented when you are working with Solaris, HPUX, AIX, and so on, and True 64 Unix. All these are standard Unix operating systems, and they implement the concept of a thread inside a process. Today we know that Linux is a very popular operating system, and in this popular operating system what we see is, on Linux the thread is not implemented as a thread, it is implemented as a lightweight process. LWP, lightweight process, is what it is implemented as. So whenever you create a thread, it is not being implemented as a thread in Linux, it is implemented as a lightweight process. The first command you execute, the first function you execute to create a new thread, you are actually creating two threads. It's only the first thread creation API which you're using that you are going to create two threads. One will be the manager thread which is going to be created, and the second is the actual thread in which your function will be executed. Now the question is, what is this manager thread supposed to be? The threads, when you have multiple threads in a process, these threads need to be scheduled, and the manager thread does the scheduling of these threads. The manager thread acts as an intelligent scheduler. Now what does it mean? Let us try and understand. This manager thread, what it does is, it is going to schedule a thread only if the thread needs the CPU. If it is in a wait state, the thread will not be scheduled. It will be given on a lower priority. Having said that, it internally uses the concept of flags. In case you are waiting for the completion of a certain thread, in such a case, the flag will be set to indicate, yes, your wait is complete, you can come onto the CPU now. So that kind of an implementation, it uses the flags internally. When you create a thread, when the thread is created, you are going to specify the function which has to be executed in that thread. Let me show you this particular piece of code which we have here. So here is my first thread, which we are calling it as first worker. I have, while I is less than or equal to 2, put as first worker at time.now, so it is going to display the time, and then sleep of 2, sleeping 2 seconds, and then you are incrementing the value of I after it comes out of the 2-second sleep. Then you have the second worker, you have a similar piece of code. Here you have a j is equal to 0, and you have the same kind of a code. Started at certain time. You are creating a thread. How do you create a thread? By using an API called thread.new. Having explored object-oriented programming, having seen the creation of a class and the creation of the object, we understand that when there is a .new, it is actually creating an object of a class. So here is where you are creating an object of the class thread.new of first worker. So you are executing that function in the new thread. After creating the new thread, you are giving a sleep of 2, and then you have a thread.new second worker, and then you have a t1.join and a t2.join. What is this supposed to be? Let us try and understand. The join is a method. What it does is, this join method is similar to the wait method if you work with system calls on the Unix operating system. With system calls on the Unix operating system, you have a fork. The fork creates a process, and then For the child process to complete execution, the parent process waits using a wait system call. Here with threads, instead of wait, you are using the function called, the API called join. Join is going to join, meaning wait for the completion of the thread execution. Which thread? That is indicated with the thread ID. Here in our case you have a T1.join and a T2.join. So it is waiting for that particular that particular thread to complete execution. Now the question is, why do I have the join? When you're working with threads, you have two types of threads, the joinable threads and the detached threads. In this example, in the interest of time, I'm just showing you joinable threads. Joinable is the default attribute of the thread. You could also create detached threads. You could detach the thread after creating it as a joinable thread. You can detach the thread using an API, which we are not exploring here. Let me now execute this particular piece of code, the thread.rb, the Ruby program. Let's find out what it is doing. Started at 33 minutes past 17 on 20th of April 2017, and then it goes on first worker at so and so time. Observe that at 36 the first worker started. Note that between the first worker and the second worker we have a sleep of 2, and that is the sleep of 2 you are seeing here, 36 to 38. And then you have at the same time 38, you have the first worker coming up, and then you have the second worker, and then the first worker, and then the second worker. You see that they are coming almost the same time. Now what I will do is, I'm going to modify this code. I'm going to modify this code. I'm using a notepad, and what I do is, here we have a sleep of 2 here. I'm going to give a sleep of 1. Let us find out what it does when I'm executing this code. When I do a sleep of 1, observe that between the two there is only a 1 second delay. So I have a 32, 33, 34, 35, 36, 37. I have introduced a 1 second delay between the starting of the first thread and the second thread. And incidentally, both the threads, if you observe, both the threads are sleeping for 2 seconds. Both are sleeping for 2 seconds. So this, if it is starting at 1, and then this is the second, and then this is the third, so it is going to come in that sequence, 1, 2, 3, 4, 5, that's what you're seeing, 32, 33, 34, 35, 36, 37. So you have two threads which are getting executed parallelly. Observe that the thread functions are not dependent on each other. The two are independent thread functions, meaning they have to execute independently. Any doubts far? Any questions? Any doubts so far? Any questions? When you look at it, the answer is yes and no. Now you're wondering, how is it yes and no? Yes, because both the threads are in the same process. When I say that, when I'm working on a multi-threaded application, let me show you the code. When I'm working on a multi-threaded application, what happened here was, originally, so let me get this guy here. Originally, this is my first process. This is my process. So let me call this as a process here. This is a process. But the moment I give a thread here, the thread.new, now this what I am having will be my main thread. This will become my main thread. Because I did not have threads earlier, I called it as a process, but now that I have threads, I'm calling this as a main thread. This is my main thread. Now this is the child thread which I am creating. Actually speaking, as I mentioned, the first thread which you created, actually you did not create one thread, you created two threads. When you gave a thread.new, what you did was, you first of all created a manager thread. You created a manager thread. So this is where your manager thread is coming. Along with the manager thread, you also created a child thread. This child thread is where the actual code is getting executed. This child thread is where the actual code is getting executed. So this is your child thread. So now what happens is, in this child thread, the moment you give the child thread, what you did was, you had that particular function. So the child thread needs some job to do, and that is what you specified with the function. And that function you called it as first worker. This is the first worker. And this started execution. Now what happened was, in this particular application, you have given a sleep of 2 in both the cases. You have given sleep of 2 in both the cases. Now I will modify this program, and what I will do is, I have a I is equal to 0 while I is less than, let us say, 20,000. And here you have a put as first worker a time. I'm not going to do that. I'm going to put as, and I'm giving a x. And I don't give a sleep now. I give a I is equal to I plus 1. J is equal to 0. J is less than 20,000, or let's say we give 2,000 rather than 20,000. And here what I will do is, instead of x, I will display y, and again here also I am going to remove the sleep. Okay, and I will do something here also. The sleep also I am going to comment this out, and this join also I will comment out. Put as end dot, no, that also I will comment out. That's okay. Okay, and now what I do is, I go here and I execute the thread. So let us see. It said started the thread at this time. After doing that, it did not show me the x and the y. Remember, I was expecting the execution of x and y, but it did not show me either the x or y. Why is that so? Any answers? Let us find out why it did not execute. Note that as long as the main thread executes, the child thread also has an opportunity to execute. But if the main thread does not execute, the child thread does not get the opportunity to execute. Now I am just commenting on, I am just removing the comment of sleep of 1, and now I am going to execute this code. Let us find out what it does. Observe this, it is giving me x. It is giving me x. It is giving me x. Okay, and now here also I am giving a print. Now what I will do is, I will give the sleep of 1 after creating the second thread. After creating the second thread, I will give a sleep of 1. Let us find out what it does. Observe that there is x, y, x, y, x, y, x, y. But if you observe carefully, it is not giving you equal number of x's and y's. It is not giving you equal number of x's and y's. It is not that it is giving you x, y, x, y, x, y, x, y, x, y. Few number of x's, few number of y's. Observe here. Observe in this particular place, there are only 3 x's. But before and after, there are more number of y's. Before and after, there are more number of y's. So this is clearly visible that there are more number of y's as is expected as compared to x, which is telling you that the way it is executing internally, it is dynamic. It is not static. So now I will remove the sleep of 1, and let us find out what happens. I'm commenting that out, and I re-execute. It is just giving me the started time. Now let us try and understand what you did with the join. With the join, join, what you told is, you are telling, I would want to wait, I would want the parent thread to wait till the two child threads completed execution. I would want the two threads to wait for the child threads to complete execution. So what I will do is, I will just comment out the T2.join and I will execute this. So here is what it is doing. You are having the X and Y's being printed. You told that you wanted 20,000 of them, and then you have the end. Now what I will do is, I will further modify this. I will remove this put s as well as this put s, and what I will do is, I am going to execute this and I will give greater than out xy, and let's find out what is the size of out xy. The size of out xy is 4002. Where did it come from? 4000 is the 2000 plus 2000. That is the reason why it got out. Observe that if the numbers were different, let's say instead of 2000 I make this 3000, will it show me the entire 3000 in my out file? We don't know. We will find out. So let me give a dir. Observe that it is 5000 here, that is 2 plus 3. But what if I increase this to 10,000? Will it still show me? Let us find out. $12,002. Here I am doing a T1.join. Incidentally, the amount of time it is taking is so small, due to which the whole thing is getting executed. But if I had a really large number, I may not really expect the whole program to be completed, because the moment first thread completes execution, it is going to come out, because I am not giving a T2.join. At some place you will have a break even and it will not match. Observe that here it is at 5683. Note that I have given such a huge number here. It is maybe in crores, but it is just showing you 5683, even though here it had shown you 12,002. Here at 5683 it has gone. As I mentioned earlier, it is dynamic, it is not static. Because it is dynamic, it has come out immediately. Okay, so once the first thread completed execution, it did not wait for the second thread to complete execution, but now if I do this, it is going to complete that execution and come back. All that number which I have given, the entire processing has to be complete, only then will it come out. I'm just showing you here what is the size of dir now. Now itself it has gone to such a huge number. I will remove that because it is unnecessarily occupying space on my box. So, sorry, used to Unix. So if I had given a much lesser number and I had executed, it would have come out quickly as compared to what we saw. So here is my 12,002. This is the 10,000 which I have given, and I have given the join. The join is going to take care that it waits for the child thread to complete execution. Join is going to take care that it waits for the child thread to complete execution. The concept of thread synchronization is available in Ruby threads. You have the concept of semaphores, you have the concept of mutexes, you have the concept of different kinds of locks which are available in multi-threading in Ruby. Whatever functionality which you have used in on the operating system, you would find that similar functionality is available with Ruby. Any doubts here? Any questions? Let's move on to see what we have at the front end. When you're working with TK first came into picture as TCL-TK. Now what is this TCL-TK? Let us try and understand. TCL is a programming language. This programming language TCL is more popular for its extensions as compared to the programming language itself. It's a very powerful programming language. It is extensively used. It was extensively used in terms of testing in a lot of in a variety of projects. But it was more popular for its extensions. TK is one of the extensions which has made TCL popular, and we see that TK is available on a variety of platforms. Whether it is Windows, Unix, Mac, you have TK available on a variety of platforms. The code which you write is cross-platform and it adapts to the local environment. What does it mean? When you look at the graphical user interface which TK offers, when you're working with Windows, the Windows graphical user interface has a certain look and feel, whereas the Mac graphical user interface has a totally different look and feel. Similarly, other operating systems have different look and feel. If you're working with AIX, it's a totally different look and feel. Solaris is a totally different look and feel. So this way, depending on whatever is the look and feel of the local operating system on which TK is getting executed, you'll see that TK adapts to the same environment like graphical user interface. When you're working with TK, TK offers geometry managers. You have three geometry managers. You have grid, placer and packer. You have three geometry managers. So depending on what you are comfortable at and what your application finds it comfortable, you may use one of those geometry managers. A geometry manager is nothing but a way to place your widgets. Now the question is, what is a widget? A widget is any object which you have. Any object which you have is referred to as a widget. Now what is that supposed to be? Let us try and understand. Let's say I have a text box. Text box is referred to as a widget. Let's say I have a radio button. The radio button is referred to as a widget. I have a text box, a check box, I have a label. All these are referred to as widgets. So when you're working with widgets, the widget has a certain attributes and a certain list of methods, a certain list of attributes and certain list of methods. When you're working with graphical user interface, we need to understand that graphical user interface is nothing but event-driven programming. As it is event-driven programming, we will first be drawing the graphical user interface objects, that is, we will first be drawing the widgets on a window. After that, we will be associating some events with the particular widgets. So whatever events which you associate with the widgets, those events will be having some event handlers. The event handlers will have associated piece of code. Let us go on to see what we have in this particular file, tk1.rb. Says require tk root is equal to tkroot.new. Having studied object-oriented programming, we understand that tkroot is a class and .new is the method using which you are invoking the constructor, and root is the new object which you created. In that, you are specifying a title. Title says good afternoon folks, and then you have a tk label.new of root. So you are passing the root object to tk label.new, and in tk label.new you are giving something that is good to see you explore tk, and then it talks about pack, and you are having a certain list of list of attributes and their values. So you have pad x, pad y, those are the attributes, and then you have looks like this is giving me a challenge. Sorry for that. Okay, so what we will do is we will execute this tk1.rb. Let's find out what it does. When I execute tk1.rb, it is showing me something. Let us read this. What is here? It says, "Good afternoon, folks." Look at that. That is the title of that particular window. And then inside the window, you have "Good to see you explore TK, the universal GUI, thanks to TCL." So this is what you saw from that particular program, that is tk1.rb. So when I see the contents of tk1.rb, I get to see that. That's what it is showing you. Okay. When you're working with TK, because it's a graphical user interface, it has widgets. Each widget has a lot of attributes and methods. Each widget has a lot of attributes and methods. When you're talking of attributes and methods, a lot of attributes may be common to a lot of classes, and a lot of classes may be having unique attributes and methods. Because it is graphical user interface, you will have a lot of similarity between different widgets, and a lot of differences too between widgets. So those similarities are implemented in the form of attributes and methods. Let me show you a second example. In the interest of time, I'm just going slightly fast here. Sorry. So here I have tkframe.new, and you have 2 frames, and then you have a button, you have 3 buttons. Let me just execute this for you. Let us see what it shows us. Observe that we have tk1.rb executing. I have not stopped it. Here is your tk1.rb. Now I am going to tk2.rb. Let us find out what it does. So here is what it is giving you. It is giving you 3 buttons: button 1, button 2, and quit. So I click on button 1. Observe this particular screen here. What it shows when I click on button 1, it says push button 1, message on console. Push button 2, message on console. Quit. It's going to exit. So here we see that it is giving you slightly more functionality in the tk2.rb. So now I am going to open this in Notepad and show you what we have. A quick list here. So you have the background red and background yellow. So when you saw this, you saw the red and yellow. So this is the background red and background yellow. So this is what you saw here. These are the 2 frames which you created. These are the 2 frames which you created. And then you have the tk_button.new. So you have indicated, here is my frame 1, F1 is my frame 1, that frame 1 is what you're using here, and similarly it is in frame 1 that you are creating another button. This is called button 1, this is called button 2. And what are we doing with this? Let us try and understand. We are giving push button 1, message on console. Push button 2, message on console is what you have given, and then what you have done is you have on quit, you have given the command called exit. So here the command is print, here the command is print, here the command is exit. Because you gave an exit, it exited out. So that's what you saw. So let me re-execute tk2.rb, and here is what you're seeing. So this is button 1. Any number of times I press button 1, it is giving me this message. Any number of times I press on button 2, it is giving that, and I give quit, and it comes back to my operating system prompt. So we see that this is event driven programming. So when you pressed on the button, the command which was executed was either a print or exit, which we saw here. Now let me bring up the tk3.rb. I'll first show you on the notepad what I have, and then we will see what we have. So here we have a procedure, and this procedure myproc is getting executed here, command procedure myproc. And what is the procedure? Says put as, the user says okay. Okay, that's all you have. So now what I do is I'm going to execute this tk3.rb. It's a very simple stuff though, just that how do I execute a procedure instead of a command? How do I execute a procedure? That's all which you're doing. The user says okay. Nothing much though, but then you will have to use this keyword procedure to indicate that this what you're executing is a procedure. This is similar to working with function pointers as you worked in C. Okay. Let me quickly show you one more example with respect to TK. This is TK4. So it has a checkbox, orange, banana. You have two checkboxes. So I haven't really completed that code though, but still I'll show you what we have. tk4.rb. So here is what you have. So you have check button 1 and check button 2. The text is orange, the background is orange, the text is banana and the background is yellow, and the rest of the fields are the same. On value orange, on value banana, but then we did not use the values. We should have actually collected all this, and we should have done a submit after doing the check, and we should have checked out, did you select banana, orange, mango, whatever. Okay, so this is how you're indicating, because it's a checkbox. In the checkbox you can choose all of them, so the value, the on value is different. But instead of checkbox, if you had a radio button here, then only one would be selected, so the on value would be 1 in all the cases. On value would be 1 in all the cases. So that was a quick introduction to Ruby. That was a quick introduction to Ruby. What can you do with Ruby? I skipped that on purpose in the interest of time. This was actually pre-planned. The focus was on making sure that you know what is inside Ruby, so that in case you find it interesting, you could actually use that in your projects. That is the end objective. The end objective is not to teach you this entire programming language in 4 hours. Whatever we saw, we didn't even scratch the surface of it. Yes, we do have services supported. You have SOAP, all this stuff supported by Ruby. Any other questions? tk2.rb. You want me to open it in Notepad? So here what you have is, okay, that fill X what you're seeing if you look at it carefully, you would find that this is like a key value pair in your in your uh, in your hash. In your hash, you have the key value pair, right? It is on similar lines to that. So here we did not see anything there because there was no filling which was visible here. So when I execute it, it is just showing me like this. You're not seeing any fill as such. That's the reason for that question. When you're working with TK, you have, if you have not explored TK earlier, I would suggest you download the TK, the TCL TK. You have active TCL, which is available for free download on Windows, and go to the CHM file, the CH. It's a compiled HTML file which is available on your Windows as help, and there you would find all the attributes and the meaning for the attributes and the methods which are available with each of these objects. So here what you're seeing is the barest minimum I have shown you. Okay. Okay. Let us go to the specific question, pack. The reason why I did not answer this question is on purpose, because I mentioned the three geometry managers. One is the packer, the second is the placer, and the third is grid. So this is the packer. Now what the packer does is, it is going to pack the objects. It is going to pack the objects in whatever size you have. So this is what you have. This is the size you have. In whatever size you have, it is going to pack. So observe that when I expand it horizontally, the two buttons are on the left. That is actually one frame which is on the left. That is frame F1 is on the left. Frame F2 is going on the right. And in between, whatever space is there, in case you had a third frame, you could place it between the two. Now, why is it that it is on the left and right? Because pack side is equal, side left, side right. That is the reason why it is being kept that way. So it is filling with nothing in between. But incidentally, here we have indicated fill X, but you're not having anything in between. When you look at the other geometry managers, you'll see the placer and the grid. In grid, you are going to specify the X and Y coordinates, XY as well as relative XY, relative to the current frame. When you're working with TK, what are you seeing? First of all, you're seeing a canvas, which is the one which is at the bottom. On the canvas, you have the frame. On the frame, you have these two buttons on the left and one button on the right.